Looking at opposite angles in a cyclic quadrilateral are supplementary. What does that mean, supplementary? Opposite doesn't mean outside the circle. So, yes, it means they add up to 180. So opposite angles in a cyclic quadrilateral are supplementary. And all it means is it's quadrilateral, so a four-sided shape within a circle. Okay? And the opposite angles are supplementary. So if we do an example of that. We're going to draw in our any kind of four-sided shape within this. And then if I try and label this, so this is, let's call it A, B, C, D. Now I'm calling these little A, B, C, D. Unlike yesterday where we were defining the angle by the legs in between it. Okay, so which two add up to 180 in this? If it's... Alright, so we can just put A plus C is equal to 180 and B plus D is also equal to 180 degrees. If I go to our circle theorems, I'll put that back up in a second. Here is the example of it. Opposite angles in our quadrilateral within the circle are always going to add up to 180. Isn't that nice? Yep, it will always.
What if you bring the other corner? Oh, yeah.
So like that?
Bring the other corner.
Which one?
Okay,
this
the
one?
ones on the bottom, like up to the top. What if you, like,
So as this one gets smaller.
No, like the ones that are on the bottom. Ones on the bottom. If you bring the bottom.
Which one? The left or right one? The left one?
All the way up to the top. And then you bring the bottom. That's not a quadrilateral.
It is, but it'll not be a quadrilateral whenever this angle in between them gets to, whenever this angle in here gets to 180, because then this will become a, what type of shape will it be? A triangle, okay? So the closer that this gets, this is getting closer to 180. This one is getting smaller and smaller and smaller.
And what if you bring that one like this?
Well, when it reaches 180, this one has to be 0, so it will be a straight line.
But what if you bring the one on the bottom? Up there.
So you want them all up in the same place?
Yeah.
What, so up here?
Yes. What, dude? Oh my god.
So this angle in here, the blue one, is still opposite this one. But it's, we're just making it, if I pull it all together. Again, the same thing's going to happen. It's going to eventually end up being a straight line, okay? Whenever these are all, or it's all going to be one point, I suppose you could actually say. They are not going to give you something like this. It's like work out this angle here, okay? They will make it nice and obvious what they're going for, okay?
And can you prove these?
These can be proved, yes.
The T word.
Yep. Thiel's theorem. This is the one that Lily used yesterday. So this says if you've got a straight line going through the center point from one side to the other, which is of course the diameter, and it is connected to two chords. The two chords will always meet at, say again, Jaden, 90 degrees. So these are always the types of shapes that you are looking for.
What's the hardest that these questions can get?
Well, I'll give you some of those that you can practice, okay? It's just when they start putting them all together, that's when they get tricky. So any two chords connected to the diameter will always meet at right angles. Okay, so that is Thiel's theorem. And again, we can quickly see that on this one. It doesn't matter where this triangle is, as long as the line goes through the diameter and we've got two other chords, it will always meet at right angles. Put it around which way? That way? Yep, the same thing. Okay, this angle in here is 90. Okay, because this is 270 the whole way around. So it's just the opposite of that side, okay? It depends what the question asks for. You know, if it asks for this specific angle in here, you would give 90, okay? All good? And the last one we want to look at today before you practice some of these is the alternate segment one. Yes, alternate segment theorem. And this one, oops. Okay, so for this one, you need to draw in a tangent to the curve, okay? I want my tangent. Is that a tangent that I've drawn?
No.
Nope. It has to go through one point, so I'm going to just move it down. Okay, and then we have got, I like to think of this as, or I remember this one, as if it is a yacht on the horizon, okay? So this is my yacht. It's a big, massive sail. This is the horizon, and this is the sun in the background.
Wait, what?
Okay, so this is like the sail,
When we say
okay?
seal,
The sail of the boat. The sail. And this is the horizon, and this is the sun in the background, okay? And
does not make sense. Yeah, the flat part of the sail has to go like
well, I can change it if you want.
like okay, look, it's like yeah, no, but like the short.
Which way would you like me to draw it, okay?
Okay, she's correct. Draw like
Draw one line going like that.
no.
Right.
No. Go okay, wait.
You
Draw
have to put the tangent
wait,
in a
okay, wait,
different
no.
place.
Draw it straight up.
I don't necessarily, okay, well, I'll draw it going slightly straight up, okay?
Okay, and then do it like that.
Like that.
No, down one.
Like way down more. Yes.
Yeah, there you go. The tangent is a little one. And then set it.
Better? Okay. Point is, it doesn't matter as long as you got a triangle with one point on the tangent, okay? And I purposefully didn't draw this line going through the diameter because it doesn't have to go through the diameter, okay? So for this one, we have this angle in here is always equal to this angle over here. And this angle in here is always equal to this one up at the top.
What if your thing isn't drawn like that? Wait. And you redraw it. This is
So it doesn't really matter how you go about drawing it if I just do another one.
what?
It's like a
No,
lot of shadows.
it does.
Wow.
Getting very arty now. So that's still a tangent.
You
And
draw like the weird sail you had before.
I can draw any type of scale I want. Now remember, this is just an analogy to help you remember.
David, you have any sails
Yep.
for you?
Oh, come on,
My
work.
gosh.
Lady's personal project. Weird other physics. Okay, no, it wasn't. Wouldn't work.
It was not. It was just.
Okay, so it could even be, it can be like this, right? So if I was to do that, then this angle in here is the same as, which one?
The little one over there.
Top
This one.
left. What? Really? That one?
Yep,
Wait, where?
top left.
Why? That's what I said. Okay, cool. Are they like opposite? Yeah.
Yeah, you kind of think, so if it's this one, then I go straight up and then down, okay? So straight up and then down, okay? And then this one in here is equal to this one. Okay, this will be easier to see when I bring it up on the little, where is it? Oh no, did I close it?
I'm still recording.
Yeah, just for this last one. So here it is. So it doesn't matter where your tangent is, okay? This angle is always the same as this one, so they just mark in the two. Okay. So they're showing this whole thing, okay? But if I bring this over, you can see, always kind of think of it as the angle in here is equal to this one, okay? And it's like a little sail. Isn't that pretty? Not so much now. Okay, so let us, using that knowledge that we have, practice a few of these. Here are some questions. Now, these are in the book, in the standard book, okay? You can practice using the sheets, okay? But this is what you want to be able to get up to, okay? These types of questions, and we can practice these over the next couple of days. So we've got the same shape. This is the segment one. Except we've got 3 of these, yeah? So this is 31. This is not writing. So then this one is 31. And that means then that this one in here is 31, yep. Okay, so that's using, if I go back to here, that is using this one, angles in the same segment, yep.
Wait for C3.
Hold up. So if these are the same, if I know this one is 16, this one is 31, then I can work out this one. Because angles in a triangle add up to 180. And then I can work out this one because angles in a straight line add up to 180 as well. Okay. Yep, Lily?
For that one,
This one?
is that a right angle for 58 and that angle on the shaded angle?
No, that would only be a right angle if this line went through the center point, if this was a diameter. And we don't know that it does.
32 isn't the angle next to 58.
Yep, this is 32.
And it's a right angle.
So, yeah, well, that so happens to be a right angle, yep. Just by coincidence. So this actually is, even though it doesn't look like it, yeah, it is actually the diameter. It's just badly drawn, but yeah, good point. That is the same as that. Okay, so it's kind of just spotting all these little tips and tricks. Just to kind of go back to this one, even though most of you have done it, you're looking for certain shapes, so Z shapes. So this is the shape that we're after. So this angle 29 is the same as this one. And we've also got this is the same as this because of our segment. These two are 29, I can work out this one because they should all add up to 180. And once I know this angle, I can work out the one we want because both of them have to add up to 180.